Is today's security good enough for tomorrow?
Clearly, no.
The aggregator is the blood flowing to our veins.
Perhaps the set-top box is dead, but to be replaced by streamers.
Legacy always lasts longer than you think it will.
Drive customer experiences and create new opportunities for carriers to engage with their customers.
Open and free does not mean easy.
The network is like a living organism.
If I give you $100 million, what would you do with it?
Hello, 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 and good morning on the last session of our Connecting the Dots Super Track, session 9. And I think I need to give awards for people who have almost been in every one. So here from Millicom, in how many have you been? Almost all? 5 or 6. Anybody else who's been to 5 or 6 of our sessions here on the Connecting the Dots track? Okay, you win.
What's the prize?
What's the prize? The prize is knowledge and insights. That's what it's all about here. As you saw in that little trailer, so it's working with tier 1 operators, leading vendors that are at the forefront defining what the industry is going to experience in the next couple of years. So that's what we try to bring here in these sessions, these insights, tips, and learnings. And that's what I do in my day job. So I'm running a Munich, Germany-based consultancy, working with some of the leading tier 1 vendors and operators, telcos, pay TV in Europe, such as Deutsche Telekom or Vodafone. Excited to be here as your moderator today with a fantastic panel. So we have Lyle Mix from Shaw Communications. Big applause for the gentleman, please. And Gwendol Simon from Synamedia. So let me join you here. Before we jump into the topic, 50 Shades of Latency. I wonder who came up with that 50 Shades topic here. 50 Shades of Latency with QoE, quality of experience, and scalability. So before we jump in, maybe a few words on, please introduce yourself and your company. And Lyle, I'll let you go first, please.
Sure. My name's Lyle Mix. Of course, I'm from Shaw Communications. My role is Director of Video Technology, really responsible for the onboarding of all forms of video content, the processing, the distribution to all of our outlets, which is satellite, legacy cable, and IPTV.
Thank you, Lyle. And Gwendol.
I'm Gwendol Simon. I work for Synamedia, which is a technology vendors for video pipelines. We cover the end-to-end pipelines from the encoding to the delivery. And I'm working as an architect for the CDN part and doing architecture's role like innovation and R&D development.
Okay, and of course, Synamedia does a bit more than that. I remember times where I was at Nagra, your best friend.
Yeah, we do all the video networks delivery, and we also have a business unit doing all the security matters, including watermarking and protection of the content.
Perfect. Good. So 50 Shades of Latency. It, of course, suggests that there is not one way to do latency, not even one way to look at latency. Let's do some definition, not too dry, please. So when we talk about latency, what do we mean? How do we measure what's important to know? Who wants to go first?
Sure. So really, I think what we're focusing on today is more about the end-to-end latency from the moment a live broadcast is happening to the point on which the customer receives signal in their home. But, you know, there are some other connotations where it's really network latency or the latency in the processing and packaging of the content. But I think today most of the discussion is really around the end-to-end.
Yeah. You see the same?
Yeah, it's also related to the glass-to-glass terms, which comes from when you capture from the video cameras to what you display and what you can show on your TV.
On your sky glass.
Yeah, yeah. And so this is something where it includes the primary distribution and then all the processing plus the delivery. And this is especially complex for the OTT world, where you need to segment the video and then you need to buffer. So you need to take into account a lot of different modules in the pipeline.
Okay, and what do we, so latency, yes, that's there. Then we talk about low latency, we talk about ultra low latency. What is low, what is ultra low?
So what is normal before, maybe?
Yeah, okay, what's normal? Yeah, let's start there.
I mean, the initial recommendations from Apple when they released the HLS was to have a buffer of 3 segments at the video player side. And each segments were 6 to 10 seconds, so it means that you automatically had more than 30 seconds delay between the captures to the display. And so with what the whole community realized that it was too long in comparison to broadcast. And so we had to go for low latency, which is new delivery systems for reducing the needs for such buffering and the need for waiting for the segments to be ready on time. And so we are talking here about 6 to 10 seconds approximately in production.
And what is ultra low latency?
And so ultra low latency is any attempt to go below this 6 seconds, which is faster than the broadcast glass-to-glass latency. And so the only problem, I would say, that the ABR technology that we have developed can hardly reach this kind of limits. So here we are talking about less than 2 seconds or even less than 1 second. So the sub-second latency glass-to-glass is kind of a challenge, but that requires new technologies to be developed, such as WebRTC.
Where does it matter? Because if I go on my Netflix, I hit the play button, yes, I don't want to wait 30 seconds, but I mean, there I don't need latency. What are the use cases where latency really comes into play and is important?
That's really usually live events. And, you know, some of the biggest complaints that we see today is, you know, I'll see the notification of a goal on my phone before I actually watch it happen on my display. And that's you know, it's a comment we get from customers. It's a comment most IPTV providers get. So, you know, just to shrink that end-to-end time helps address that problem. There's another side effect of ABR, and that's everything is unicast. So when you're in a sports bar watching a live event, you end up in a situation where none of the TVs are synchronized. You know, one TV will be ahead of the other TV, and while shrinking that latency helps with the differential, that continues to be a problem, even if we, you know, just by the nature of ABR and unicast. So that's a problem that we see, and I don't know how to fix it. You know, perhaps we need smarter players to be able to, you know, and encoding systems to be able to identify, you know, the time synchronization that most clients should align to. It's that effect where you're, you know, you hear the cheers on one side of the bar and what just happened?
Yeah, or it's your home and your neighbor shouts, goal already, and you don't even have seen the penalty happening. Yeah. What other use cases are key to take into account for low latency?
So for low latency, mainly this is the synchronization of the different people watching the game with different kind of networks for the delivery. And then for ultra low latency, why would we need to go even below this 5 seconds? Then there are many new services coming around betting or auctions. And this is where you need to have this less than 2 seconds delay, because somebody attending the event in the real life, in the real world, can notify you about who just scores the basket or who just swings the ball before you can see it. So you could bet before the actual events to be displayed on the screen. So this differentials is something that we need to have as low as possible to allow the whole population using this kind of services, which is maybe not the full population, but to be able to bet in all security.
Mm-hmm. Is it easy to get to, let's say, low latency? Are you there, Lyle?
Yes, I am.
Good.
Is it easy? Well, the newer technologies are all taking care of reducing that latency gap. You know, CMAF and the new AHLS specs help with really defining a way to reduce that to the clients. The smarter clients supporting, you know, the ability to fill the buffers, even though it hasn't received the entire segment. All of those types of things do take care of it. It's still, it's probably good enough for what we're trying to accomplish with the mass of customers, but you know, we're not there yet, and it takes a long time to get those new technologies embedded into all of the supply chain to deliver the content. So we're still working to get there, but I do believe it's achievable.
Randall.
Yeah, I mean, for the CD endpoint, it's something which is a bit challenging. We have some low latency deployment in production now, but it's a kind of a recent feature, so it has less than one year, and we are still working on it to improve the scalability. What is complex is that usually for the ABR mechanisms, the client requests the segments when the segment is available at the edge servers. And with the low latency, the edge server is supposed to deliver the bits before the full segments to be available. And so you need to have range request or CT, the joint transfer encoding systems, which is a bit complex to set. But well, we managed to have that running today, but it's still something that requires a lot of attention from developers.
Okay.
Yeah, it's running. We see it in demos, but to actually get it into production is yet another cycle of work to make sure that it's complete and seamless.
So what are the key challenges in the end-to-end chain that are the hardest?
So the CDN is one part, and you need to have a very good synchronization between the origin servers responsible of the encoding of the packaging of the system and the CDN part. So you need to have to be sure that the CDN will not forward too many requests to the origin, or otherwise the origin can become the bottleneck of the system. And due to this range request, it happened that the CDN is a bit lost in all these technologies, and so that can be detrimental for the origin. Otherwise, in theory, it works.
Well,
not in production.
Like I say, we've seen demos, so that type of thing. But the reality is there's just so many components within the delivery chain, and you know, it takes time to harden and ensure that those things are all working together, and a lot of components you need to upgrade without interrupting what you're actually delivering today. So
yeah,
legacy
legacy
it's
always.
It's a long pole activity to get there. Just to in reality to be able to deploy something like that on mass scale.
Yeah, like we saw Rob Swerow in RDK saying in the video, legacy always lives longer than you think. And that might be the biggest problem.
Yeah, once you know it works and it's out there, it takes a long time to shift to the next thing. It's true.
Yeah. Okay, so I see the benefit for the user, synchronization. And do I have other benefits for some components in my network, like the clients? Do I get other benefits by having lower latency? Does it get more robust? What else do you see?
I see a lot of factors that play into not just the latency, but also just overall improvement of the delivery. For example, as you move to the higher compression codecs, it just reduces the amount of traffic you have to send over the network.
Yep.
So those are options too, because just reducing the amount of traffic you have to deliver improves the ability to get it across the network. But at the same time, these new technologies that we need to take care of, you need to look at the use cases and what's critical to feed the customer experience today, and where are the business cases for these ultra low latency type of solutions. So it's a technology problem, and it's a business problem at the same time.
Yeah, so the ultra low latency is completely based on the different technologies. And
correct.
so WebRTC is not based on segments, not based on ABR. So we have to get back to the old time where we are sending RTP segments. And so this is something which requires redoing the whole pipeline, kind of. And so you need to have a new infrastructures or at least an infrastructure that enable multiple technologies to be delivered on top of it. And this is yet another investment. So this is why the business use case is significant. So we expect betting services to be profitable and valuable because people, they play their actual money. So maybe you can take a bit of this sense for each streams, and that can cover the extra cost of these new technologies. WebRTC is intrinsically less scalable than the regular low latency or dash HLS delivery. So we are talking about 5 times less sessions per servers. So this is something that you have to take into account as well when you are doing this kind of services.
That's true. Gambling's a very interesting one. Depending on the region, they all have different, government rules around the state or the province, and so where they allow off-track betting, where they allow in-game type of betting, the expectation would be that there's some very low latency signals that are available. The reality is that you don't need to. The size of that segment of customer is much smaller than the typical live distribution of content.
Of course.
So the need to scale to the same type of level isn't there. So some of these new technologies can satisfy that if you can scale at a manageable level. The cost per channel, cost per signal at the same time can typically be higher because there's revenue in the gambling industry, and those folks, if there's money to be made, they'll pay for it. So it is something that we see an opportunity for, but we haven't totally built out the business case yet. So
it will surely come.
It will surely come.
And another aspect is that we deliver regular.
Gwen will get a bit closer to the microphone.
Yeah,
please.
we deliver regular TV channels, 24/7. But these betting services, they are only a couple of hours per week or a couple of hours per day at best. And so it's not like, CDN is already trying to address these peaks points, but here it's not even peaks, it's that there is absolutely no usage of these technologies for most of the time, and you suddenly have 20,000 people to serve. So you need to have a very elastic and flexible infrastructure to support this because it's not used most of the time.
Okay. When we don't, let's not go to the ultra super low latency. I just invented a new term. So low latency, I think, is there a trade-off? Let's say, okay, I go for lower latency, but that gives my clients, my player, more time to buffer. Can I increase robustness through that way? So I can say, I could go to 6 seconds, but I give my player 10, so he has more time to deliver all the chunks, and I don't need to, like, everything is running on the edge. Is that a benefit, or?
It can be if you are not particularly in urgency in terms of latency. So you can use this low latency technologies and exploit this range request, CTE delivery for improving the quality. But usually what we do is that we want to display it as fast as possible. And what we can play with for addressing the quality problem is the rate, the frame rate that we can change if we want to make the quality a little bit more constant.
How do new codecs contribute to all that problem? Do you expect new codecs? I mean, whatever's coming now. We had several discussions in the session before. So how do some of the codecs contribute to ultra low latency? Will it be easier to reach it in the future, or is the codec not the key problem?
The new codecs I kind of address this, but the new codecs actually introduce new opportunities to improve on what's there, because they're taking advantage of the ability to deal with microsegments or the ability to, start pushing out a segment before it's fully encoded, that type of thing. The other part of it with the new codecs is, of course, the client support. And the client support, they're in new development. There's opportunities to optimize the clients to be able to leverage those new technologies. And finally, just the smaller size of the traffic, the segments are smaller because they're compressed more, maintaining quality, and that's just less traffic to move across the network. So all of those things combined help improve those extra seconds you need to get to shrink off the end-to-end.
Okay.
Indeed. Although the recent codec requires a lot of computation as well. And so
You're adding more seconds somewhere else.
Latency as well. And so there are some trade-offs to do. You cannot have, if you run for WebRTC, you cannot afford to have the extra quality that you can have with JVC, because you cannot do the multiple passes of your codec. So this is also something where you need to pay attention when you implement your encoders, and this is why this is really a full pipeline settings to have.
Okay. How do I even understand, and maybe Lyle, how do you measure glass to glass? Because you're not in my home to measure. So how can you observe the state or the various states of your network in the first place?
I can talk to that one to a degree. We actually don't measure the entire glass to glass. What we can measure, and what's probably the most valued portion of it, is from the point the client makes the request to the point we push that request out back onto the CDN in response. So that helps us identify what's happening within the transcode, the packaging, and any network latency to get to the edge. At that point, we can assume that, understanding what the client does, you kind of layer that in on top. And we call that, we've got an acronym we use, it's called TTMS. It's a measurement that we use to tell the health of the network. We can collect that data from CDN and analyze it and look at it and mark where we're seeing issues and problems. And it's a measurement we use today, and it's something that we'll probably continue to use, but it truly doesn't give you the end-to-end latency.
But it's a good approximation. Do you have tools to get closer?
Of course. The research community is working today on some ways of allowing the clients to provide some information about what's going on home. And this is named CMCD, which is a standard which is developed with CTA and SVTA as well. So with CMCD, we will have more information from the client side. And one of the challenges now is to reconcile the information from the client and the log that we have in the CDN. And so to have a global view of it, and eventually to be also able to forward these logs up to the encoders and the packagers if we want to have this glass-to-glass system. So the missing point, which is the client, the last segment is something which is under development in the community. So we need the video players to conform to this standard. And then to integrate that into the log, so probably 2023 in production.
Okay, that sounds good. Let's get back to our topic. Our title will also all about the topic: latency, QoE, and scalability. So, what is the relationship? We can sum up the relation between latency and scalability. Why cannot have both?
So what we explain, I think, is that when you go to the ultra low latency, you have to do some new compromise in terms of the encoding, because it has to be faster than the 1 second encoding stuff. And the compromise by using WebRTC is making scalability much harder per servers. So
is it harder just cost? A couple thousand more Amazon instances, or which is a good argument.
Yeah, sure. I mean, one of the technologies that we promote is the edge CDN, meaning that we want to have the servers as close as possible to the end users, because WebRTC is very sensitive to packet losses. So if you have a premium location in the network, you can have much less packet loss and so much higher performance. But you don't have infinite numbers of servers in the edge. So
that's true.
That's where the infrastructure is limiting. And so if you use AWS or any cloud providers which is out of your networks, you may well have some lower quality of experience with this WebRTC systems, which is you don't have time to get back the packet that you lost in the path.
Okay.
See, and that's correct. Speaking from the operator perspective, right? You know, putting caches into the network on wide scale is very close to the edge on wide scale is a big augmentation of what we need to do for capital infrastructure. So at that point in time, it's about the business case again.
Of course.
So can we have both? Perhaps. Do we need both is more my question, because do we need that level of scalability, or can we move it back a little bit and be able to satisfy a lower number of customers that need that use case? That really is our stance on it.
Yeah, and so the WebRTC technologies requires much more CPU at the server side, because you need to have some processing for each single connection with the end user. So it's not a stateless servers just getting the cache and delivering what is in the cache. It's something which requires tracking what's happening for each individual. So you need more CPU. And our cache deployment, our usual cache deployment, we are not that strong in CPU, because the usual cache is not CPU intensive. So we also need to change our servers, which are deployed in the edge of the networks, if we want to support this kind of technologies.
Okay. You mentioned probably one of the strategy to get to low latency is the edge CDN. So is that the preferred way? Is that the only way? How do I get there? What's important to know about edge CDN?
So I mean, the edge CDN is having higher performance in terms of delivery, because of the close distance between the end users and the servers. The other advantages of edge CDN compared to the cloud delivery or global CDN delivery is that you have only one version of the stream coming to your networks, when your network operators going through the internet exchange point or the POP, the point of presence connections. And so you have reduced transit cost in terms of networks. So this is something which is, in the end, a higher value for the network operators. This is at least what we promote for for this kind of delivery. And with these latency issues, you cannot afford having too many packet losses. So you need to have something which is fast and good quality, and when still in the network.
Do you see that a viable approach for you, Lyle?
I do. I do. It becomes the cost equation. In order to meet the needs of the business case, I can see it as long as we can generate enough revenue to do it, right?
Yeah.
And at the same time, I know Gwendol's been talking about WebRTC, another low latency technology, which really relies on UDP type traffic and things like that, is SRT. And I know that SRT can really reduce the latency as well. From an operational standpoint, it doesn't scale well either. And in order to sustain it, it gets expensive. So it seems like all of these really low latency type of deliveries, that it is difficult to try to scale them at large, but if the business case is there,
Why not?
We just do it.
Yeah.
Yeah, as a technology vendors, what we try to do is to develop all these technologies and to have all the pipelines possible, so that if customers come and say, hey, I want to have this betting because I believe the business case is now good enough, then we could deploy in our infrastructures for this.
Absolutely.
Yeah, and we don't know for other use cases that may be coming, right? So,
Exactly.
Gaming or some of these other technologies that keep coming out is
Metaverse,
Yeah.
VR
Oh,
applications.
yeah, everything, right? So putting edge computing to reduce the latency on even those types of use cases, I know we haven't done the business case, but I gotta feel that this is just gonna be a problem that we're gonna keep working on for the next decade to come.
Okay. So I'll open the floor for some questions. Think about what questions you would have to the two gentlemen. Before we do that, I have a question, and you saw it already in the trailer. What if I gave you $100 million? What would you do with it? For Shaw, sorry, not for bikes, boats, and retirement mentions.
Yeah, I'd definitely be investing in our ability to augment our processing infrastructure, our CDN infrastructure, and when it specifically in latency, there's a lot of R&D that goes into that, and invest in some of that R&D.
Would 100 million be enough?
100 million would get us a long way, that's for sure.
Good.
For the size of Shaw Communications, it's definitely a long way. But yeah.
Okay. And Synamedia?
I would use it for betting for the summit.
So there's your use case.
Yeah, don't bet against the house, I guess, right? So.
No, yeah. One of the investment that we need to do is having the capability of testing these technologies at large. And so this is always an issue with CDN, or a challenge with CDN is to test what's happening in the real world with this kind of scales. And so being able to do some deployment, which is not production deployment, but realistic enough, requires some money. So I would put it there, I think.
Okay, great. Any questions from the audience? So we have a microphone here. Please tell us your name and your company, and shoot the question. It should be on.
1, 2, 1, 2.
Yes, it works.
My name is Idris from DriveNets. So I have a question in regards to the packet loss, right? So let's say a customer watching a live event, or let's say just a cable TV, right? And let's say the cable, the channels are delivered over IP network, not like IPTV, right? Not directly cable. How would we measure, let's say we know there's a packet loss in the network. I'm a hardware vendor or software vendor, right? I know there's something happened on my device, like my customer's network. How would I know that, without getting too many calls, that, okay, there was a packet loss and the like user experience of the user was affected? The quality of experience. Like I'm watching a football or whatever, I mean, whatever people watch here, and then there's a drop, or the picture stopped, or you know what happens when packet loss happens on a video, right? How would I measure that? What, from like not pure networking perspective, like how would I know that a lot of people are affected without getting too many calls?
So
you know?
typically, we'll see. I'll answer that in two ways. Purely from a network monitoring, when people en masse or an individual customer is having issues in their home, typically it shows a similar pattern. So we'll start seeing downshifting in the ABR profiles on the client device, and that means at the CDN level, we're actually seeing those downshift events happen.
Like traffic utilization going down, or
so with ABR, you're going to ideally you're always pulling the highest resolution, the highest profile. ABR is defined in a way that there's a ladder of things. So if the end client device is having problems, it's a smart device, it'll start requesting the lower quality content, right? And you'll see that downshift request, and that tells you that something on the client device or in the transport itself is having a problem. So that's usually what we use as a dashboard for our most common problems. Now you can apply that to, if you see downshifts on a mass scale, it's something in the network. If it just seems to be happening on that client device, then it's typically an in-home problem.
Right. Okay. Yeah, usually the way the cable operators design the network is based on regions. So if something happens in that region, I know there's a certain neighborhood or a certain area that I should be getting calls from. But if it's late night and people just don't want to call, and they just keep, like, every half an hour there's like a picture freezes, right? They're watching a football. Mm-hmm. So yeah, it's a little challenging to understand. And then when they call you, like, oh, I have drops on my TV, and then you don't really understand. It's tough to troubleshoot that. But it might be something on the, back in the network. You say maybe a multicast drops or whatever. So you're saying that on the ABR side, there are the applications, like layer 7 applications that can detect that based on a downgrade of the video?
Correct. That's one of the immediate signals. We'll see error counts, like 4 or 4 errors, because remember, the ABR content is HTTP driven, right? So you'll see the error counts on the requests.
HTTP, when you say HTTP, like what if they have a box, right, an IPTV box?
Correct.
Is that all unicast?
It's
all unicast?
The box starts, the player itself that's running on the box, the application, will start pulling, first it gets a manifest of what all of the segments of the video it needs to get, and then it starts making HTTP gets so that it just starts pulling the content. Okay. If it has problems pulling the higher profiles, or if it can't fill its buffer fast enough, it just starts requesting the lower profiles, because that will be transported quicker. Right. Okay. And so those types of patterns are common. We see them, we can detect them. Right. It helps us in that analytics. Right. It does take us time to figure out, is it an issue in a neighborhood? Is it an issue in a city? Is it an issue nationally? Nationally is really easy to define. Or a large scale city is usually easy to see, because you'll just see it spike. Yeah. But in some cases, the smaller types of issues where you've got 30 homes or 150 homes, and that's the segment that's impacted, it's definitely a lot. It takes us more time to hone in on exactly where the problem is.
Thanks. One last question. You want to answer too?
Yeah, I mean, For ABR, indeed, we have this observability tools that allows some early detection of potential problems. For WebRTC, we are not there yet because there is no notion of ABR profile downgrading. So depending on the implementation of the WebRTC gateways, which are the servers.
What is this WebRTC? So let's say I watch the ESPN on my web browser. Is that what it is?
Yeah, it's possible to do that. And so you have the servers can add layers of forward error correction, which can be used as a signal for too many packet losses for each individual sessions. But having the whole monitoring system doing that is not
Expensive challenge.
So maybe it seems a longer discussion. Maybe we take it offline after the session. Thank you for that. And do we have maybe, we already run out of time, but I want to have one more question. If anybody has a burning question, then we can take it. If not, then I want to there's one. Yeah,
hey,
please
Roman.
jump. Please go to the microphone, so otherwise people who watch the stream can't hear you.
Roman from Shaw. So just from a global perspective to see where we're taking the proactive approach from the kind of issues which we see sometimes with pixelization, back to this one, where we can improve to determine it ahead of time, even before the client, see the issue, or maybe to prepare for, sometimes there's events with a lot of, users who are watching, when the network can be more busy. Are we thinking about this proactive approach, how we mitigate it ahead of time?
Thank you, Roman.
Thank you.
Roman, I think that's directed at me.
Really?
So, yes, we want to get there. Let's be honest, today we've been operating IPTV for a few years now, and we definitely are at a point in time where we have early detection. I know that we are looking at opportunities to do the self-healing as the next step, and the guy sitting next to you is also working on some of that. But at the end of the day, we do really need to work with our solution providers to help us pull together a self-healing, more proactive, automated type of correction when we see errors. But definitely, we've seen great improvements where we were blind before. We now see issues happen very quickly.
Thank you, Roman. Thank you, Lyle and Gwendol. Great discussion. Big applause for the two gentlemen, please. And thank you, dear audience, for being with us here in the session. This is the last one of our Connecting the Dots. It was a pleasure to have you. Have a safe trip back home and see you at one of the next conferences or trade shows. Thanks for being here.